So just my surname, D-O-C-K-T-R.
We're good. We're recording.
Okay.
Thank you.
Hey, good evening, everyone. Thanks for coming. So it's kind of a special night for me. My son has still a week of spring break vacation, and he's seeing me the first time present on our technology. And I have this very funny story from a friend of mine, Venkat Subramanian, amazing speaker. And when he took his son to his one of his presentations, the son said after the presentation, "Dad, you must have really good friends." And he said, "What do you mean?" "This was so boring and no one left before the talk was finished." So let's see, Tomo, how you will enjoy that. Okay, so quick question at the beginning. Who of you is using primarily Maven? And who of you is using primarily Gradle? Okay, so in any case, the presentation is interesting for both of, whatever build tool you're using. So before we go into the technology part where I show, what you can do to improve developer productivity with build tools, let me talk more about why are we doing this? What are the problems that we're seeing out there in the industry, right? Everywhere, everywhere, wherever we're going, right? I'm now in a business for quite a while, right? And we've been in the trenches with, the banks on the East Coast, most of the major players here in the Bay Area. So we have really good insights in terms of what the challenges are, right? And in a way, that is kind of where we are as an industry when it comes to software, right? It's when it comes to efficient production of software, we are far away from where the other industries are, right? If you look at, car industries or chemical industries, those are all academic disciplines, right? You can make a PhD in chemical process engineering, right? Or in automation engineering. Those are well-respected crafts with a tradition of 40, 50 years of research. And when you look at the software industry, 10 years ago, the build guys were the second-class engineers who were not good enough, basically, to write production code, right? At the same time, the leverage, right, of build and CI technology for the productivity of software engineering is tremendous. So there's a mismatch, right? A big mismatch, and it's starting to change. Right? You can see this now that just with the naming, right? Build engineering teams, or release engineering or configuration management, they're starting to rename themselves. They're now more and more dedicated teams calling themselves developer productivity team, or at Twitter it's called engineering efficiency. So things are changing, and organizations understanding how important their role is, but we're still at the beginning, right? And what we see all over the place are patterns that are basically unprofessional, right? So people responsible for the build, right? How do they make their prioritization, right? Either it's based on some anecdotal stories, or that is probably the reason, that is probably the biggest problem, right? Without any data, or very often, the prioritization is solely driven by developers complaining or not complaining. So basically, the build infrastructure is the perfect state if no one is complaining. Right? That's the only metric that counts, right? And the one who complains the loudest gets the job done, right? So, and we see this all over the time, right? All over the place, right? I'll give you a typical example, right? And it's again, a person is saying, "Oh, I have this problem all the time, out of memory exception," right? And sends an email to the VP, right? What a shitty job the build engineering team is doing. They often get the attention they want because the build engineering team doesn't have the data to show, hold on, all the time, yeah, 2 times a month, that's not good. But we have this 20 other people that have a much bigger problem they suffer from, right? But there is usually no decision criteria like that organizations have. So it's kind of, it's a Wild West, what gets done and what people get focused on. And there is a reverse side of that. We see this very often, right? So let's say an organization did some push to make the build faster. They got the build time down from, I don't know, average build time, let's say from 18 minutes to 8 minutes. Good on them, right? And now they're saying, well, no, everyone is happy. Now we don't want to hear about that anymore. So even if you tell them, well, you could get it down to 1 minute, they have this attitude, hold on, it's no longer a problem. Which is crazy. It's super unprofessional if you think about it. There is an option to make things dramatically faster, but they said, no, we just did this improvement, everyone is happy, and that is our criteria where we prioritize our work. This is like, I mean, imagine you would run a car factory like that. It's unheard of, right? But that is where we are with software. And I see this all over the place, right? It's based on there is no vision in terms of we know what we're doing. We have clear goals. We understand this domain of software delivery better than our engineers. We're serving our engineers, but we have our own vision where we want to take the company when it comes to manufacturing process. This is not yet, you don't see this at many companies yet, right? So, and we need to break that, right? So what do we need to do, how to break this, right? So one is you need to be well resourced, right? When we meet organizations and they have a 300 people engineering team and they have 1 or 2 people taking care of the build, that's not enough, right? It's just too complex and you cannot get the job done, right? So what we see in the Bay Area, people are usually more willing to invest into that area. So we see more well-staffed team here than, let's say, in other parts of the country. But still, it's something, the organizations that are very successful, be it a LinkedIn, a Google, a Facebook, right? They made very consciously and already 10 years ago the decision that they heavily invest, right, into their developer productivity teams, right? And to a point that 10% of the employees work now in what they call foundation at LinkedIn, right? So, but it has been worth it for them, right? And you can see the economic results of that. So, so it's definitely an area where you need to make an investment. And I'll talk later about how to make a business case for that. But then we also need organizational and cultural changes, right? So what do I mean with that, right? So often, first of all, people have to appreciate that, especially in the age of microservices, modeling CI and build, right, is a very complex domain. It's as complex as a business domain. It's pioneering, right? There are no cookie cutter solutions out there, right? So it needs to be appreciated, right, that this is a complex domain, and engineers who work on that domain, their job is as complex as the people that work in the application domain, right? And then the other problem we see is a lot of finger pointing in that area. So in general, I would say the build tool is probably the most cursed tool, developer tool in every organization, right? And often that means you also like to curse about the build tool team, right? And often it's not fair, right? You have situations, let's say a developer makes a decision, oh, you know what? In the big monorepo, let's start using this new annotation processor that whatever generates me getters and setters, I don't know, right? Without any idea what implication it has on compile time. And then the next day, the same person is complaining, oh, the build got slower, right? Damn build tool or damn build engineering team, right? Why are they not doing their job, right? We see it's a little bit contrived, but not too much, right? We've seen this all the time. There is no accountability, right? What affects the quality of service and the time of the build tool is not just the build logic and the plugins the build engineers write, right? It's also many decisions developers make. You know, be it languages that have faster and slower compilers. I don't want to name anyone here, right? But you get the idea, right? So and we need to have a culture of appreciation and of collaboration where people are accountable and where it's not just this finger pointing that we see at many places. So who would, let's say at your organization, would you say you see friction between the people responsible for build and for CI and the developer groups, or is it mostly a very functional and happy relationship? Or okay, it's on Zoom, I understand. So okay, but today we want to focus on the second part, right? The vendors need to provide better solutions, right? So except for a very few companies in the world who say, we don't care about vendors, we create our own IDE, we create everything we need, right? We have 1,000 people working on engineering efficiency, right? There are not many. There's a Google, a Facebook who can do that, but otherwise, you rely on what is offered in the space, and what is out there yet is not good enough. And it's the big mission of our company to change that situation, right? In one important area I will talk about later, right? And I will show some of that this evening. And the other thing is, we need software manufacturing as a discipline. I want to see a PhD thesis about monorepos, right? Or doing microservices with monorepo versus multi-repo, right? I want to see deep research in that area. It's definitely deserves it. It's very complex. We're talking about the most complex engineering pieces in the history, right? And yet it's not much of a research topic, right? There are a few professors who work in that area, but it's that, so that's, I think, where we have to develop as an industry to take this also much more serious, right? And go deep. Anyhow, so what can vendors do, right? In this area. So for me, very important is faster builds, right? And it cannot be fast enough, right? So we will talk today about caching. I will talk a little bit about distributed builds later on as a roadmap thing. But then a very important part is build analytics. So who here in the room could give me an answer if I asked them, how many local builds are your developer running every week? Who could give me an answer? Who could tell me that number? So as many as what? As needed. Yeah, okay. So that, yeah, in an exam, I'm not sure how many points I would give for that. But it's like, but you know what I mean. I want to make so let's say someone comes to, let's say, you know, I have to, in my role, you know, as a CEO of our company, if someone comes to me and said, hey, we have a problem, right? Say, we need 2 people, our local builds are too slow. It's a big problem. Everyone is complaining about it. I say, well, I would say, okay, 2 people, that's whatever. So and so much money. So how much, so what is the business case here, right? How often do they run local builds? And then how much faster can we make them? And then I can do some simple math. And when I get as an answer, well, I don't know, right? But they're complaining about it, right? How can I make a good business case? Because maybe they tell me, you know what? They're doing 10,000 local builds per week, right? And we can make it 5 minutes faster. And then we'll do the math. 2 people, you need 5 people. You know what I mean? So anyhow, so we need data. We need desperately data in that area to make decisions. And we'll share quite a few interesting stories tonight about where the lack of data has led to some very inefficient scenarios for particular organizations, right? So we need data to optimize the machinery, right? And not just once. It's like application performance management. You need to do it continuously because the inputs are changing all the time. Code bases are changing. You do refactoring. You open up new locations, right? And then so one thing is optimize machinery. The other aspect where you need data is also optimize behavior and collaboration. So for example, we see all this. Say you would migrate from Maven to Gradle, right? And Maven people are all used to type in Maven clean. Always do it clean. With Gradle, you don't need to do that, right? So now you wanted to have the data. So you give this presentation that you don't need to do clean anymore. And then I would like to know how many are still doing clean after 1 month, right? And then I would say, I would like to see that. Oh, 80% of the builds are still executed with the clean. I think we need another session, right? And I will talk much more about other aspects of collaboration, right? Where data can really help. And the third thing is faster mean time to repair failures, right? The CI build is broken. Why? It worked. The local build worked. The CI build is failing. How often I had to ask myself the question, and the only friend I have is the console output on Jenkins or whatever you're using, right? So we can do better than that, and we will talk about that later. Okay, so just to get some clarification regarding our products, right? So Gradle Inc. is the company behind the Gradle build tool, right? Fully open source, Apache version 2 build tool at 7-8 million downloads per month, right? It's considered one of the fastest growing source millions of users, and yeah, we're very, very happy supporter of that tool. I founded that a while back. And since a couple of years, we have introduced a commercial product called Gradle Enterprise. There's also a free tier, so we'll talk a little bit about that today as well. And the focus of Gradle Enterprise is to improve development productivity, and I will talk about how it does that in detail. So first of all, how does it work, right? So, you have, we have a free service, but the full functionality is available via an on-premises version of Gradle Enterprise that you can install within your firewall, right? Or you can install wherever you want on AWS, Azure, right? Your own data center, and you can, with not much work, right? It's very easy to connect every Gradle build and every Maven build in your organization with Gradle Enterprise, either with a Gradle plugin or Maven extension, right? And then once you have connected those builds, right? Whenever now a build is executed, right? Be it on CI or be it by the IDE on a command line, whatever the build does and touches, data about that is sent to Gradle Enterprise. Plus, that's the other part of it, the infrastructure part, it provides a build cache. So who of you is using the Gradle build cache? Local or remote? In CI. Yep, exactly, yes. So it comes with a remote cache backend. For Maven, it also comes with a local cache. Gradle build tool has a local cache as part of the open source offering. And it provides also all the analytics around build caching and how to make that effective. Right, we'll talk about that later. And build caching is about reusing build output, right? And don't build stuff you don't need to build. And it would be the first topic we talk about today. It's on the topic of speed, right? So what is a build cache? So if you think about Gradle tasks or Maven goal executions, right? The compile goal, the test task, right? All those things have inputs and outputs, right? And the idea of a build cache is, well, if the inputs have not changed, the output can be reused from a previous run. And that has a tremendous effect on build speed, right? And what we, so Gradle users know this now for quite a while, right? What is new, we have introduced that concept since March 1st this year, also into the Maven world. So if you have a mixed environment, and so this now also works for Maven. So examples for that are, let's take the compile task, right? So the compile task, as inputs, you have the source files, the compile class path, the Java version, the Java compiler configuration, the output are the .class files, right? But testing is extremely effective also, caching is extremely effective also for testing. So look at the test task or the Surefire plugin. The inputs are the test source files, the test class path, the test JVM configuration, and the output are, what are the outputs? The test results XML, right? So caching is a generic feature, right? And this is probably where you get the biggest benefit usually from the cache, right? Test avoidance. It can be huge, right? I will show you some examples in a second. So, but the key thing to understand, caching is a generic feature and applies to all task goals, right? Could be compile, testing, source code generation, absolutely, Java doc, check style, PMD, custom tasks that you have. So give you an idea, we were working with a several hundred engineering team, and they were doing a lot of source code generation. So whenever they went to work in the morning, they checked out everything, they did a git pull, right? And then before they could start working the IDE, they had to say, we need to get the latest, right, from version control, and then have to generate all the sources, and then they can start work. And it was a 15-minute step for every developers at the organization every morning, right? And now with the build cache, well, the sources are already generated, right? So this whatever 10, 15 minutes was brought down to 30 seconds, right? So that's just one example, right? And the only thing, what is also important to understand, we don't cache jars, right? Why? Because to take the .class files locally and archive them in a jar is as fast as get a zip with all the .class files, right? You know what I mean? So from an everything that is pure I/O, caching usually doesn't make much sense, or copying from A to B, right? As soon as you would do filtering during the copying, maybe then it's a candidate for caching. But it's a so caching is interesting for every task that has some computational kind of effect, right? When it's pure I/O, you don't need to cache, like copy. Clean obviously is also nothing you can cache. Okay, so let's talk about the different levels of caching, right? So one thing Gradle is doing since version 0.5, right, is what most of you know as the up-to-date checking mechanism. So the way how this works, right? This is the Gradle project itself. It's about 1 million lines of code, so it's not small, but I just built it before, right? And what you can see is I just tell Gradle, hey, create all the classes, right? But this is very fast because you can see 415 tasks were up to date, right? Every Gradle user knows that. So what exactly, if you think about it, this is kind of using the cache. If you think about it, right? What we basically doing is all the sub projects, right, have a build output directory, right? And when nothing has changed, right, we just say, hey, we don't need to rebuild it, right? So the build output directory is a cache, right? But it's a limited cache because let's say you switch between branches, right? So you build A, branch A, then you go to B, you build branch B. Well, your build output directory is overwritten. If you now switch back to A, you have to rebuild everything again, right? You have only the build output directory really is only a cache that caches output from the last run, right? The real advantage we get from that is that it also allows for incremental compile and things like that we can reuse that output, right? But again, we only use the output with the up-to-date checking from the last run. It's very effective, but it's also limited. So now the second level cache is a local build cache, right? And that works independent of the output directory of the build. That's just the directory on your disk. Has nothing to do with the dependency cache, right? That, you know, the third-party libraries, right? It's really for the task and the goal output. And so this is a directory you have on disk, right? And this caches build output over time. So I want to explain this. Let me go back here. Here we go. Thank you. Yes. Thanks for the reminder. There's some Zoom situation where there is a time in the evening where they have to reset something, right? Yeah. I forgot to mention it. Sorry. Yeah. So I was. So I'm.
Hey, folks on the Zoom, we might need to just do a quick restart. So if you ever just join again. Thank you.
Who has ever used the build scan? So cool. A few people.
Do they actually slow your build down when you scan it?
Marginally, right? So basically, not. We work with super large monorepos, right? 2,000 sub project, and it's not significant, right?
So you could leave it on and it wouldn't necessarily.
Absolutely. The data collection is super cheap, right? Yes, I will demo it in a minute, but I already. So that was the kind of preliminary question, right? So, and so who of you would like to have faster builds? Or is that just curious? Here we go. Okay, so let's think about how caching works a little bit more detail, right? So the first level cache that I just demonstrated is pretty simple. Whenever you run a Gradle build, right? Gradle analyzes the inputs of a task, right, and creates hashes. It's not timestamp, right? It's all content checksum based, right? And then when you run it the next time, it again creates the hashes, right, for the current set of inputs. And if they are the same, say, hey, task is up to date, right? It doesn't need to be executed. Right? So what we're now doing for the build cache is we create the same hashes for all those inputs of a task, and then we create a unique key. Unique in the sense that it uniquely represents that set of inputs, right? And then we store the output of the task in the cache together with the key, right? And that cache survives the build, right? When you do a clean build, all your input directories are gone, but not the content of the build cache, right? So then the next time you run a task, right? Whenever you run a task, the right Gradle is now calculating the cache key and then asking, hey, cache, do you have output for that input? If so, takes the output out of the cache, unzips it into the build directory, and doesn't execute the task for the goal, right? And that is for Gradle. For Gradle, the local build cache is part of the open source distribution. For Maven users, that is part of the Gradle Enterprise Maven extension, right? So if you look at, I have this small project here, SLF4J, right? All of you, I guess, know this. So it has 11,000 lines of code. So it's pretty small, right? And it's built with Maven. So let's just run a Maven clean verify. And this is with the build cache enabled. And what you can see is that this took 11 seconds, so it's usually about 10 seconds or so. And you can see things here loaded from the build cache, right? Test compile. Or you can see the compile task, right? Loaded from the build cache. You can also see where's the Surefire plugin. Come on. Here, Surefire plugin test, right? Loaded from the build cache. So 10 seconds, right? So let's execute this with no cache enabled. And this is how you would run it without the Gradle Enterprise Maven extension. And this is the interesting conversations we need to have, right? This is a small project. How long will it take without the cache? Much longer than in the previous run, that's for sure. 26 seconds. So here's now the interesting situation. No one would complain about 26-second build time. No one. You would say, are you crazy, right? But once you've experienced 10 seconds, you don't want to go back to 20. It feels really long, right? And that's where we need to go in an industry, right? So it's not just about the super big projects, right? We still have projects that have hour-long build times, right? And it's basically killing this organization, right? So for them, it's more like a life and death question to solve that. But here, it's an amazing opportunity to give developers a lot of time back, right? Especially if they execute, if all together executed thousands of times a week. So if you think about it, for Gradle users, right, the local build cache is mostly effective when you switch between branches, because otherwise your up-to-date checking will do the job, right? But for the switching between branches, it's cool, right? For Maven users, you don't have up-to-date checking. You always have to run a clean build. So the cache is your only friend for Maven, right? So because for clean builds, the only thing that helps you to make it faster is the build cache. So to show you a more substantial project. So who of you is using Spring Boot? So the Spring Boot project itself is at this point in time built with Maven, and when you run, it has I think 270,000 lines of code, right? And when you just compile and run a unit test, it takes 20 minutes and 25 seconds, right? So by just plugging in Gradle Enterprise, the build time goes down to 3 minutes and 22 seconds, right? Doing some optimizations, right? They had some issues I will talk about later, typical issues that make cache ineffective. The build time went down to 2 minutes and 47 seconds, so 7x improvement. There are still some goals we don't cache yet out of the box, like check style. Once we cache those goals, the build time will be 11 times faster. We will be at 8.9% of the original build time. That's a game changer, right? If you work on such a project, that's really changing the fundamentals, how often and how early you get feedback. Because what we are seeing is, right, we had just an organization that say, oh, we have a big local build time issues. What did they finally decide to do? The developers don't run unit tests locally anymore. That's one way to speed up the local build, right? Kicking the can down the road, right? And now they have a large CI queue, and and they don't have enough CI resources, and this is essential. Company that can make such an improvement in build time, it will be so much more productive because developers will ask for feedback more frequently, right, and much earlier. So, okay, and so one of the things when you do caching that can be kind of that are tricky, right, is the inputs need to be stable and portable. What do I mean with that, right? So, for example, if you have a source code generator that adds timestamps to the generated sources, the cache key will always change. So you will never have a cache hit for the compile task, right? Oh, new key for the sources, new key for the sources. I haven't built that yet, right? Make sense? So then you need to think about, okay, how can we normalize that? How can we change the source code generator potentially to maybe, to either not create a timestamp. So JuxB, for example, is a tool that created all this irreproducible output. They now fixed that in their version. But that is definitely something that kills cache efficiency is timestamps. We offer you in Gradle and in Maven some ways to tell out. What people like to do is they like to add something like a build.properties file with a timestamp. Let's say this is version 2.1 and then the date when it was created, right? So this build.properties is often part of the job. That means now for your test runtime class path, it always changes. You never can reuse the test output. And then you can tell Gradle, you know what? Please ignore build.properties in the runtime class path of your test for calculating the cache key, so that you have cache effectiveness. There are some weird tools out. I shouldn't say weird tools out there. There are legacy tools out there that sometimes put absolute files in a generated output, right? This is the report destination, absolute file path, something like that. Let's say you have a code quality report that puts in some absolute file path in there. Then you have good cache effectiveness with your local cache. But we're talking about the remote cache that is shared across machines, you will have not a good cache effectiveness because everyone will have different absolute paths, right? So, okay, non-deterministic ordering. So there are issues, so you have to invest time into fixing this and making sure that this is not introduced, and that is also where the data will help you. We'll talk about that in a second, right? But that's something, those are the challenges, right, to make caching effective. But it leads you to more, in general, to more good thing, right? So this is good hygiene in any case, right? And then The third level caching is, you mentioned that, the HTTP cache, the remote build cache, where you can cache results across builds in multiple nodes. Let me, so and then you have it set up like this, right? So you have a local cache, you have a remote cache. The remote cache can have multiple child nodes that replicate from each other, right? And the way things usually work is so that when CI builds are run, before they run a goal or a Gradle task, they calculate the cache key. If and then they ask, do you have output for that cache key? If the remote cache says no, they will then run the task and store the output in the remote cache, right? And when a local developer runs the build, we usually recommend that developer builds don't store output in the remote cache. We say the remote cache is also used for release builds. We want to only have controlled environment feed the remote cache, right? So when a developer runs the build, the first thing that they check is the output available in the remote cache? No. Is it available in the local cache? No. Then they would build and they would put the output in the local cache, right? But they would not put it in a remote cache. Another reason is developers often have dirty working copies with just changes they haven't committed yet. So they would put a lot of stuff in the cache that is by definition no one else would be interested in, right? So CI builds read and write to the cache, to the remote cache. Developer builds only read from the remote cache. You can configure it however you want, but that's usually what we recommend, right? And the effect of remote caching on CI builds is amazing, right? So that is where we see tremendous, often 80% average build time improvement, right? So if you cache is like an SSD into the computer, right? It's like it's that kind of. They probably will never be anything like that in the next years. It will make it so much faster than build caching, right? If you were, this is the Gradle project itself. So also to share some of the let's say performance improvements by the different mechanisms, right? When you run clean build with Gradle without a cache, right? Testing compile is 1300 seconds, so that is about whatever more than 20 minutes, right? Just compile only is 3 minutes roughly. And if you do a clean with a remote cache, the overhead of the cache, if you have a reasonable network connection, is not significant, right? So that gets build times down from 72 to 38. And that is the big jump. Everything else you see here, clean over the cache, is 47.28. That's nicer, but nothing compared to the first improvement, right? And then up to date is 12 seconds and 7 seconds. So yes, those are all very nice improvements, but even if you just do remote cache, that's the biggest improvement you will get from when it comes to build avoidance, right? And for CI jobs, if you think about it, people now moving into the direction of disposable builds. So who of you is working towards disposable builds on CI? Is that who of you knows about ephemeral builds or however it is called? Is that a topic? Yeah. So what is your experience with that? Yep. So no local state anymore on CI, right? So then the remote cache is again your only friend, right? To make CI builds fast. Particularly, what you very often have on CI, you have a pipeline. You have many jobs. Let's say one is just compile. The next one, quick feedback. Run a few tests. The third one is run all the unit tests. The fourth one is run the integration tests. And you rebuild so many of the things over and over. And so you get really analyzed for such a fine-grained pipeline because always everything gets compiled and stuff like that. So with the remote cache, you can do this. It's fine. Perfect. Right. Because the cache will make this so fast. Right. So yeah. I will not. There's some smart stuff we do, but I will skip this for today. So, so I want to move to the next topic, right? The next three topics: observability, debuggability, and collaboration. So we just had a proof of concept with the large Maven builds. They had build times, believe it or not, it's a 1,000 plus Maven submodule build. They had build times of with integration 6-7 months. So, and then we started. So, and then of course they said, hey, we want the build cache, right? And we had amazing improvements, but we also collected super interesting data. For example, we could show them, hey,
get rid of it.
your CI machines, their hard disks are so slow. So with your local machine, creating all the jars is still just gets better hard disk, but it takes only 3 minutes. But on the CI machine, creating all the jars created something like 20 to 30 minutes. You just have super slow hard disks, super slow, right? And they had no idea, right? It just was just this black box build, right? And so once you start collecting data, things get really interesting. Here's the hard disk, and you learn things about how you can do it. It's amazing. So now I asked already who knows build scans, right? So in Gradle Enterprise terminology, we call it build scan, the data set that is produced by executing one build. Right? And there are two ways you can make use of build scans. Either you have to create an enterprise instance installed, right, in your organization, or we have a service called scans.gradle.com for Gradle and build, and you can publish build scans for free. Right? You don't have all the features, I will show all the analytics, right? But it's already super helpful and cool tool, right? For those of you who don't know it. And for Gradle, it's super easy, just do your Gradle build with --scan, right? And it will be uploaded, and you can look at the build scan. So when you look at this. I can show this with Gradle, right? So I run this again. This time I run it with --scan. Can you read that in the last row? Still make it a little bigger. So I run this now with --scan, and it's asking me, publishing a build scan to scans.gradle.com requires accepting Gradle terms of services, right? We want to make sure that you understand we upload something here. So I say yes, and then what you can see is this URL at the end of the build, right? And if you click this URL, it takes you to the build scan, right? And oops, why is this taking so long? It usually doesn't take that long. This is, here we go. That's. Thank you. Maybe the designer wants to show his work off a little bit. Come on, guys. That's ridiculous. Yeah. It's okay. What's going on here? Those free services. Here we go. Oh no. Okay. I'm not sure. So, so what you can see here. Oops. How can I? Browser is a little bit. Okay. So here you get some basic idea, or not some basic. First of all, you get a basic idea what happened during the build, right? It was green, so it was successful. What was executed, when it was executed, right? And it shows you everything from console log to deprecation warnings to the timeline, to understand how well the build was parallelized and which tasks were executed, deep performance analytics, we will do that in a second, all the dependencies that were used, all the plugins that were used, infrastructure, right? So you get and we will dive into some of those. So you have a really deep insight of what happened, right, during that build. And you can use that data for many interesting purposes, right? So, and when you look at the SLF4J project, right, here, maybe what I want to show you first, how easy it is to connect a build to Gradle Enterprise, right, be it from Gradle or Maven. So what you can see for Maven, we just have this, you just have to drop an extensions XML into your Maven project. And it just says, hey, apply the Gradle Enterprise Maven extension. And then it catches that from Maven Central or from your Artifactory or Nexus, right? And then you need to do one more thing. You need to configure the extension, which usually means to tell where the Gradle Enterprise server is, right? And that's it. You commit that to version control. And the next time the developers check this out, you know, the cache will be active and the data will be sent to Gradle Enterprise, right? So it's really easy to set this up. For Gradle, it's as simple as applying a plugin, right? And also specifying the URL. Okay, so, at this point in time, oops, at this point in time, just show it for Maven. Similar concept, URL at the end of the build. In this case, it's published to our internal instance, right? And here you see everything that happened during the build. Okay, so now what I want to talk about is, why is that data interesting, right? So it's definitely very interesting when you have a troubleshooting situation, right? But it goes way beyond that. So let's go to our own instance that Gradle Enterprise instance that we use internally at Gradle to develop our software. And so this is from the last 7 days. And if someone asks me the question, how many builds did you have in the last 7 days? I would say 106,972, like in a Toyota factory, right? I have this number. And then if someone asks me, hey, how many CI builds did you had that failed in the last 7 days? I would say, let me check, right? So 589, right? So how many local builds did you have that failed? How many builds were run that were dirty with uncommitted changes? 520, right? How many of them, right? And then you could, you know, you could do things like, if you had different teams, how many builds were run in Seattle, in Bangalore, right? So just this basic data, right? How many failed, what types of build failed, and you can filter them according to the user. If this user is saying, oh, I always have this out of memory exceptions. Well, let's see, right? Let's see how much Hans is complaining about all the build failures, right? Let's see over all time, right? How many failures did he have? 11. No, come on, Hans. Can't be that bad, right? So, but, and all that is stateful. So you can share, you can say, hey, Hans, you only had 11 failures, right? In the last, you know, whatever, over all time. So, so you can also use that. Let's say if you have some weird issue, right? With the build, do I have a good, let me quickly check something. So for example, we had one weird issue here. Where the docs DSL metadata task, it failed now and then, right? And then and when you look at the reason why it failed, it was some oh no, hold on, summary, see failure details, a non-serializable exception. Maybe it was a race condition because of parallel builds, right? So now I can say, okay, I want to put a query on this task, right? To see how much of a problem is this, right? And then you can see, okay, so far we had only 9 of those. How much do we get, right? Is this happen once a month? Is this happen? So that means you do not need to wait for angry developers. You know what I mean? It's no longer a black box for you what their build experience is, right? You can proactively check what is going on and can have an eye on things, and then can make decisions at what point you need to have a sleepless night, right? At what point you have to escalate, or at what point you say, okay, yes, it's a problem, but it's not a big problem, right? So I can deprioritize that. There's an issue, I share the issue with the guy, with the build scan, and say, hey, you know, we will work on this, but in the next sprint, something like that. Now you can manage things. Otherwise, it's so hard, right, to deal with those situations, because there's a real problem, but it's very hard to understand what is the scale of the problem. Now you can do that, right? So another very interesting thing is, right, we talked about, let's go back here. Hold on. So let's look at the performance dashboard. The moment that only works for Gradle, soon it will work for Maven. So what you can see here is when people ask, what is the average build time, right? I also often don't get good answers, right? They often don't really know. So here I could tell you, well, average build time is 2 minutes and 20 seconds, but what is the variation, right? So we show you the different percentiles. And of course, you can filter all that with the same criteria. For example, hey, I'm only interested in average build time for the Gradle project itself, right? So, and then you can dive deeper into things. So for example, what is my configuration? How much time does it take to configure the Gradle build? How much time does it take to execute the build, right? And then what you can always do is here in that screen, right, you can look for pathologies. Oh, wow, if you think about this, I can say, just look for initialization time. And then I find some builds that had 2-minute initialization time, right? And I could say, oh, what is going on here? The average time, 5 seconds, is okay. But where do those 1 minute, what is going on there? And then I could click those, right? And I could say, okay, let me see what is going on here, right? And then my first thing that I would think, or maybe some dependencies downloaded at configuration time. You see? Someone is saying, oh, my Gradle build didn't start for 1 minute. What is going on? Now they sent me the build scan, and I can see, okay, this was a build where a lot of Gradle plugins had to be downloaded. It was on a fresh machine. I don't know what happened, but I can see now, this is okay. There's nothing wrong with my Gradle build. It was just one of those builds where a lot has to be downloaded. How else? I mean, seriously, if you're responsible for build, you don't have that information, and someone's saying, oh, I have this slow configuration. How do you deal with that issue? Right? You cannot give us easily a satisfying answer to that person, because this is not reproducible. The next time the person runs it, it will be fast, right? So this is, it's fantastic, right? So, yeah, please. I would say no. Yes. So you're saying, is that somehow replacing the dependency log? No, it's complementary. So the question was, does this information that we now capture all the dependencies, right, replaces the dependency log plugin? It's a very good question, right? Because we're even thinking about, can we use that in that way? But no, actually, we work together with Netflix and dependency logging is now part of Gradle Build Tool Core, right? So because the thing is, you want to make it part of version control, right? You want to be able to commit the log file to version control. So that's why I think in this case, it's a better place that it lives in the open source product, right? We will do more in the area of dependency logging, more from a security point of view. But in terms of reproducible builds, no. The opposite is the case. Is now a core feature of Gradle build tool since 4.7 or 8. Yeah. So. Oops, what is going on here? I still have this typo in here, sorry. So other thing that is very interesting to look at is, so if you look at this, and this is, I mean, this is spectacular. We hadn't had that 20 months ago, right? 16 minutes in average per build is saved by build avoidance. 16 minutes. Right, so that's 89% of the time. Right, that is worthwhile investing. right? This is, so, and then we can look into, you know, remote build caching, local build cache, right? Up-to-date checking, and where does it come from? But at the same time, you had the question, oh, what is the overhead, right, for the data, right? So the other interesting question, what is the overhead of the build cache? So because you download stuff, right? And so you might roll this out and do not realize there is this team in Australia, a small team that has not a good internet connection, and your cache server is in San Francisco. And now for them, the build gets slower because it's the build cache, right? So again, if you roll out technology like this, you want to understand, okay, so how effective is it? And then you can see, and this is, I mean, think about it. This is highly effective. The overhead in average for the downloading of artifacts from remote cache is only 0.26 seconds. I mean, it's nothing, right? I would expect that it would be much higher if you had asked me gut feel wise, right? But, you know, so it means, especially for CI, the remote cache is very effective, and we have a very good bandwidth there, and it's great, right? So now, but now you can say, yeah, in average, this is great. 0.26 seconds, you see, unpacking is the biggest part of the overhead. That is why the difference between the local cache and remote cache is not very significant, right? If you have, but anyhow, what I want to show now is, but maybe the downloading in general is no problem, but in some cases it is, right? So let's look for some, do we find some spikes here? Okay, so here we have one, you see, downloading is marginal, but there's one build where we had crazy downloading time for the cache. So again, I can go into this build scan, I can say, can go to the performance tab, can go to build cache, and I can see, okay, my average bandwidth was 16.1 kilobits per second. Okay, right. And if I now see this is the Australian team, I say, okay, I disable the cache for them for the time being, and I give them a note or whatever, right? But this is. The key thing is with build avoidance technology, right? It's two aspects that are key, right? So developers can trust them. One is reliability, and the other is if someone is complaining, you need to be able to give them a quick answer, right? Otherwise, they lose trust that you know what you're doing, right? And then they start disabling this, they talk at lunch, or you know what, actually the cache is making everything slower, I would disable it. You know how, I once worked with an organization that was sending a shell script around, it was 500 people engineering team, sending shell scripts around that they added whenever they run a Gradle build, and this shell script was deleting everything. .cache, dependencies, third-party library. They were so desperate because they had some instability and the build team could not fix it. They were doing crazy stuff. And then 500 people deleting, killing every optimization in the universe because they wanted to at least have reproducibility. And when there is a failure, they want to do not doubt the build. They want to know, oh, it's my code, right? So you have to be, if you introduce technology like that, you need to have the data, right, to be sure to make it effective, and that developers trust you, that you know what you're doing, and that you can address problems, right? So, okay, yes, you know what, this build was slow, I can confirm that, right? And you have it's a network issue. And the developer will be super happy with the answer. And I will disable, this is how you can disable it, great, right? There is an explanation. It's not this, I don't exactly know what happened, sorry, right? Which is terrible. You can just how far this goes, right? You can take any task here, right? Let's say check style main, right? And then you can see this task, and we show you you know, it was a check style task. You can see it was very slow. You could, one thing, whenever you use the cache, right? So this task, check style main, the output, it was not executed, but the output was retrieved from the cache. And we show you in the build scans a link to the build that has produced that output. So you always have a full audit trail, right? If you have some weird issue, right? Oh, I have output, it's weird. You can always go back. Let me go back to the build who produced that, right? And then you might see, oh, I don't know, in the infrastructure section, there was a weird operating system that has produced that output. Maybe we have some, whatever, line ending issue, or I don't know, character issue, right? So that's important, right? From a peace of mind perspective, you can always pursue this, right, to the origin, right? And from an administration point of view, right, you can manage all the nodes, you can define the replication. The last thing I want to show to you is on that topic, let me go back to this build. You can, oops, where is it? Build cache results. You can copy the cache key. You can say, hey, do you have an entry for this cache key? And then we tell you, yes, we have one in the California node, in the Frankfurt node, in the Sydney node. And you can say, you can download the entry to analyze it. You can just delete that entry from all the nodes. So again, you're in control, right? Yes, please. Yes. Exactly. So by default, yes. Can you say that again? Yes. Yes. I will show you something in that respect. Yes. So cache is opt-in, as you know, right? You have to add cacheable annotation. And then you can do things like, give me a second, where do I have a build scan? So let's say you have a situation where, here we go. So what you can do with build scans, you can compare them. Right? So let's say you have a situation where you say, damn, why do I never get a cache hit for this task? I run a build, and then I run it again, and no cache hits, right? You can say, hey, Gradle Enterprise, compare the two builds. And then we would show you exactly, we tell you, hey, for the compiled Kotlin task, the source property was different between the two tasks. And we even tell you, it was exactly that file that was different, right? So here, maybe there is some timestamp in there, or I don't know, right, in this case, right? Or even for that also works for jars. See, yeah, you can look, right? Hey, this is the difference between, so this directory in the jar is different between the two builds, and those are the files that are different. So it's pretty powerful, right? What we, yes, please. Yes.
All this part is that part of?
So the question was, there's a free and a paid version. This all build comparison is all part of the commercial product. The free part is a single build scans, which is already very valuable, right? That is the free part that you can upload. Yes. Thanks for the good question. So, okay, so we talked a lot about, you can see how build engineers can benefit from those products, right? Or from those features. But it's not just, it's also developers. We haven't talked much about it. So in terms of making their debugging more effective. Let's say a CI build fails, right? And now a developer is on Jenkins. We have build scan integration with Jenkins. So on the Jenkins job page, you see a link, build scan. So now the developer clicks to the build scan and says, oh, better than the console log. That's for sure, right? Much more information. But the person still doesn't understand why is it failing, right? So then what you can do is to say, you can say, hey, this was running locally, right? Successfully. Let's compare the two builds and let's look at the dependencies, right? The CI build was using version 1.6. The local build was using version 1.5. And then you can jump to the build scan and we can tell you, it's dynamic versions. 1.plus was used and the CI build was picking up a later version than the local builds. Yes, please.
Well, this is giving you lots and lots of wonderful information out there that you can click through and find.
Yes.
But I was actually curious as to what he was asking. Does it actually give you hints, give you optimizations, as opposed to just giving you lots and lots and lots of information to weed through?
Yes. So it is primarily the way it is structured, and yes, it gives you hints, but it's not in the sense, right? this is wrong, it gives you, let's say, sharp exploration tools, right? So that is, at the moment, it's more geared towards the build engineers who wants to effectively explore versus, let's say, a smaller team that says, hey, just tell me what is wrong, right? It's a focus thing, right? We have the data, and the question is a very good question, right? But right now, there is still so much we can do by making things easier to explore. And the primary users for us are larger teams, right? And build engineers, they like to explore in depth, right? It is on a list. We have a few suggestions that we do, right? So it's not like completely empty. So you see here, there is a settings and suggestions, but and the list is growing, right? Where we give you hints, but I would say it's still it's a next phase thing, right? But for us at this point, what we focus on is more the analytics parts, right? You have all this number of builds, and we ask you, hey, show me the average compile times between Windows and Linux machines. Show me the average compile time between SSD and hard disk. So we want to make it super easy to ask those kind of questions. You can do it today, but you have to export the data into a different system and things like that. So that is our current focus, right? But this is definitely a next phase thing. And there's overlap between the two, obviously, right? So, okay, so the last thing I want to show to you is, so first of all, there is a collaborative aspect here, right? Because where was this example? Was this here? So every view in a build scan is shareable, right? I can say, you know why the CI build failed? And I can share exactly that view, right? So that is so everything, every aspect, right? You search, whatever it is, you can share that particular view. So we want to make it extremely easy for developers, right? When I'm a developer and I have a weird issue with the build, I have to often make a decision. Do I now do ping pong with the build team for 2 hours? Right? Or can you send me this? What is your property files? Can you create a dependency report? Can you run the build again in debug mode 2 hours later, right? Or do I say, you know what? Not today. I move on, right? It only happens a few times a week. I have better stuff to do than work on it. So now build scans, you can say, hey, boom, this has happened. I can file an issue. So the whole, and often, but the problem is from a cultural point of view, it's dissatisfying. When I see there is a problem, I say it's so much time now to explore this together with someone that I accept it. It's not good for the culture because we want to work together on this and to improve it. Now we make it easy, right? And especially flaky build issues are so hard to work on, right? For the build team, it's super hard because they cannot reproduce it on their machines, right? So they have to somehow try to reproduce it on a different machine. So this is a big part. You capture all the data all the time so that you can do comparison. And you basically very often don't have to reproduce, you have the data to figure out what happened. So the last thing I want to show is that you can it's one of my favorite examples. If oops, what am I doing here? Gradle, build scan, quick start. So this is a very simple Java project, right? It's not worth kind of talking about it much. The project is super simple, but the interesting part here is you can customize build scans. And this is a real power feature, right? So you can create your own tags, right? You can say, okay, if the environment variable CI is set, tag the build as a CI build and create a link that links from the build scan back to the job page of Jenkins. If it's not a CI build, tag it as local. The next thing we do is, hey, Git, what is the commit ID? And then we add the commit ID as a custom value. And we add a link source to the build scan that takes you to the commit tree in GitHub, right? So the next thing is we capture the branch name, right? And add this as a custom value. And then my favorite one is status. The developer saying, oh, I haven't changed anything. Well, Git will tell us if you haven't changed anything, right? So we capture the status, tag the build scan as dirty if there are uncommitted changes, right? And also show you all the files that have been that are dirty, right? Then almost my favorite one is, we ask Git, hey, please produce a diff, right? And then we take the diff and publish, if the diff is not empty, and we publish the diff as a Git gist, as a GitHub gist. And then we create a custom link at the end, git diff, you see that here, right? That points to the URL of the gist. So now you have from the build scan a complete diff available, right? Finally, what we're doing, two more things, right? We're not capturing check style information in build scans out of the box. So at this point, that will probably change at one point in the future. So what we're doing here, and you can do this with any report, we go through all the reports, right? And we add the check style errors as custom values to the build scan. And we will see that in action. Finally, what we're doing, if the build failed with a particular failure, we create a custom link that points to the issue tracker, in our case, the Gradle forum topic, in your point, it could be Jira, where people can just click file an issue together with the build scan in the Jira issue tracker, right? So let's run this build. Very well. Oops. Yeah, come on. Okay, this build will fail by design because of check style errors. So now we go to the build scan, and you can see this was a local build, it was dirty. So developers say, I haven't changed anything. Well, no, you have, right? And you see here the link to the diff. So we even have the information what exactly has changed, right? So imagine you're a developer working with a local test that is failing. You don't know why. You want to ask a colleague for help. Just send them the build scan, right? You have all the context. Here's the link to the source, right? That takes you to the commit of that project. And then what you can also see is the custom values, right? So the Git branch name, the Git commit ID, the Git status, and all the check style issues, right? So you can have thousands of those. This really scales, right? So if you want to capture additional information, right, and you can filter for those in the search for build scans, right? This is very powerful to add more context, basically. Again, the idea is, right, create all the data that is necessary to, in many situations, make it easier to understand why did something fail, right? And yeah, so, and the last thing I want to show is, again, this is also a tool for developers, right? What we also capture all the tests results, right? And so let me see if I find some build with a failing test. So for all the failed tests, right, we show you basically the output of the failing test, and now you can share this. Hey, I have a local test that is failing, right? You can share this with a colleague, and the colleague can immediately look at this and can then see, oh, I had this problem before. I think it was related to the version of HTTP client. Ah, yes, they're using 4.6, 4.5.6, right? And then you can send this back. Hey, I think this is related to the version of Commons clients you're using. You see, you have everything in one place, right? Yeah, and we show you, right, what brought Commons clients in, et cetera, et cetera. So to wrap this up, right? The last thing I wanna mention is if we want to invest into that, we need to be able to make a business case, and that is also why it's so important to have that data, right? So, how do we assess the economic relevance or model of the build, right? How much engineering productivity do you save when you make the build 1 minute faster, right? And it's, if you have those answers, right? Or how much money do you save if you get SSD drives and all the CI machines, right? At the moment, no one has the data. I mean, to be honest, it's almost a disgrace for the industry. I mean, it's ridiculous, right? That we cannot, super simple questions, we cannot give answers for, right? And that is, it's part of the professionalization of the industry that we know this stuff, right? And can really make assessments, right? And if you were, do I have, don't. So when you talk with organizations that take that very seriously, like Tableau, right? They imported all the data from Gradle Enterprise into Tableau. Because they said, it's easy to find the 4 or 5 most kind of pathological issues, right? But once you have fixed them, there are 1,000 things you can do, right? And prioritizing them is basically, it's impossible without data. It's a lottery otherwise, right? So they invest a lot of time into analyzing, for them was always reliability is the most important thing, then performance, and then they had all this amazing analytics around, where the reliability issues over time, how are things improving? Because that is my last thing I want to make, right? My last point I want to make for today. When I ask build engineering teams or people who are responsible for the build, the question, let's say your code base is growing by 30% next year, right? Not unusual. And you make the build 5% faster. Who, A, will notice that? And who, B, will give you any credit? And the answer is no one, no one. But you have saved millions of dollars for the company. If those are 500 engineers, 30% longer build time, or 35, or whatever the effect would be of the growing code base, it would be millions of dollars, right? Millions of dollars. And you do that, and it's not realized. So it's not just personally dissatisfying, it's something is wrong with the business if someone is making an impact of that scale and it's unnoticed, right? And so that is also from a professional point of view to show the value, right? That you have created, right? It's important to have the data, right? So, okay, thanks for your time. Any questions? Oh, thank you.
Thank you.
Do you have any plan to incorporate different build tools?
Yes, very good question. Almost like, I love this. Yes, so initially it was Gradle only, right? Since March 1st, it's Maven, and we want to eventually support all major build tools, right? Sometimes it will be, so from Webpack to CMake to, what I cannot say yet, right, is we definitely on the data side can do that, right? On the infrastructure caching side, it's always the question how amenable the tools are, but absolutely, right? I would say there are not more than 10 major build tools out there in the world, and we want to eventually support them all. Yes. So what would be the one you're interested in?
I mean, our team uses, like Node.js and others. So it would be nice to have other build tools support.
And we have quite a few of our customers, of course, or more or less all of them have a big JavaScript team, and they're already asking for that. It's just a complex ecosystem, to put it mildly, right? So but we will, I mean, it's not like we're not working on it, but that is a this year or beginning, first half of next year thing, right? That we do something for the JavaScript world. There was another.
Anyone else? Yep.
So in the beginning, you mentioned distributed builds. Can you just?
Thanks for. Thanks. Yes. So that is one issue that we're working on right now, right? Because at the end of the day, there are 3 things I would say, right? We can do to make builds faster. So, so one is build caching, avoiding, reusing stuff, right? I think that is the biggest one. The second one is, well, sometimes you have to build stuff, right? Run it on multiple machines, and that is now and that is something we are prototyping right now for Gradle and for Maven, right? To basically, take a build. And we want to make it basic. We want to integrate it with the current ecosystem. So the way we want to do it in the first iteration is that you can reuse all your Jenkins agents, right? For that, we don't want to ask you to set up a new cluster, right? And the results are promising. But then definitely when you have a medium to large sized repository, right? And the idea is that, not the idea is, this is not just for CI builds, also for local builds. So you have a local build and you will be able to run that build on many machines, right? So the whole, one of my favorite topics was not just topic of today is how, so continuous delivery with small repositories. So what many people did, right, they said, you know what, especially in the Maven world, right, let's solve the build time issue by using many, many small repositories, right? The problem is you're kicking again the can down the road, right, with that. Because when you have a large repository, the beauty of that is, or when you have, let's say, a monorepo, one beauty of that is the producer it is made sure that the producer is not breaking the consuming modules, right? You always build everything, right? So, and when you now go into this multi-repo world, you say, oh, great, the producers are super happy. The builds are so fast and they're always green, right? And now the consumer have to figure out, right? Oh, something is not working anymore. So Netflix, they went down that road, and many organizations do, and there's nothing wrong with it. But they did a study that said 20% of the engineering time is now spent on debugging dependency management issues. Oh, something is not working. One of my 100 dependencies, right? There's a change in the dependency version and it has broken me, right? So how do we can get in a multi-repo world that responsibility back to the producer, right? And then what we want to do in that area is that a pull request build should not just build one repo, it should build all the repos that depend on that repo. So that, and the producer can only merge it if that build is successful. And then again, you want to have distributed builds for that. So the thing is, at the moment, people say, oh, we have small repositories, build time are not such an issue, but they're paying a price for that with later feedback cycles. And that's what we need to fix, right? For the people doing microservices with small repositories. So who of you is mostly having very small repositories? Yeah. And we see now, my favorite is what we see now, I mean, I don't want to tell any names, but I went to this company, also 800 engineers, right? So, and the first question, right, when we talk about build issues, I'm always asking, so how is your code organized? And I say, oh, we have hundreds of Git repositories. Okay. So is the code evenly distributed? No, 90% of the code is still in one large repository, which is a many hundred submodule build. And in this large repository, in this whatever 500 submodules, 80% of the code is in one submodule. So they're now in double hell, if you like, right? So they didn't have a real end game. They said, okay, we want to get rid of this monolith. So but it was more for emotional kind of, I don't know, we create now hundreds of repositories, but that hasn't solved the major problem they're having. Now they have to orchestrate all these hundreds of repositories and still have the monolith that is super slow to build, right? And what we're also seeing is an overreaction. People saying, oh, for them, monolith and large repository is the same, which is not the case, right? And then they're going way too small. I talk with teams, 30 developers, 200 Git repositories. I say, why? Right? What is going, yeah, we have orchestration challenges. Well, yeah, of course, right? So we see a lot of overreaction from monolith to way too fine-grained kind of, repository setup without having an idea of how to solve the problem that comes from that, right? But it's a separate presentation. It's one of my. Oh. Any other questions? Awesome. Thank you very much. Have a great evening.
Thanks, everyone. If you stayed all the way here till the end, there's a little bit of leftover giveaway swag on the back table from the recent Java 12 joint meetup we did with Silicon Valley Jug. So please help yourself. And thanks for coming. Check out the schedule. We got plenty of meetups coming up in the next couple months.
Thank you.